parabolas, let's review what they are. You learned that last year. So we have a parabola. So these are the terms you have to know. Where the parabola crosses the x-axis is called the x-intercept. And where the parabola crosses the y-axis is called the y-intercept. We just learned this before when we do linear relationships. But with parabola, you could have two x-intercepts. Another feature of the parabola is the axis of symmetry. Axis of symmetry. So axis of symmetry is a vertical line passing through the vertex. That's the vertex. Okay. All right. So we're going to identify these features in these examples on your right. And then we're going to do more examples. Okay, good. All right. Let's look at example 1. So let's example 1. Okay. All right. Good. So let's write down the turning point, whether it is maximum or minimum. The turning point is the vertex. So what is the vertex? The vertex is 1, -4. Is it maximum or minimum? It is minimum because it's the lowest point on the parabola. All right, that's done. And then we have axis of symmetry. Axis of symmetry is a line passing through the vertex. And what's the equation of this line? Any vertical line must be x equal to a number, and that number is 1. X equal to 1. Okay. All right. And then you can tell from the graph what is the x-intercept and the y-intercept. Okay, let me ask a student. Damien, what's the x-intercept? K. Yep. -1 and 3. Very good. So these are the x-intercept. Let's look at the y-intercept. What would the y-intercept be? -3. That's your y-intercept. All right, good. So it's pretty easy. Could you try the next one? Exactly the same question. Yep. No, you can't. Think of it this way. Someone asks a very good question. Can you have two y-intercepts? It's impossible, right? There's no way you could have two y-intercepts, but you will have two x-intercepts. You mean? So yeah, it has to be. So it could be here, right? It could be there. Y-intercept. I don't know what you're talking about. You mean, can the parabola look like this? No, we won't study this. We'll study that in year 12. It can be. It's still called parabola. Yeah. Okay, let's continue. So let's look at the next question. Turning point, whether it is a maximum, minimum. What's the turning point? What's coordinate? Anyone? -2, 0. Good. Is a max or min? Maximum. Okay. So we call this parabola concave down. So any concave down parabola will have a maximum turning point. Any concave up parabola, it has a minimum turning point. Okay, so remember these keywords: concave up, concave down. Let's work out the axis of symmetry. So, Jasmine, what's the axis of symmetry equation? X equal to, very good, -2. Let me ask another student. Jason, what's the x-intercept? Very good. For this one, there's only one x-intercept. Next one. Irina, what's the y-intercept? -4. Good. All right. Well done. Okay, we all know what to do. So it's very, very simple. You just have to look at the graph, write down what you need to write down. Okay. Yes. Yep. Correct. Yep. Next one. Okay, we've got one more page to go through, then you can do the exercise. Okay, what's this? So you have these parabolas, A, B, and C. Each of these will draw a new parabola comparing with the old parabola in dotted line. See the dotted line in red? Y equal to x squared. So we're going to compare each of these equation with y equal to x squared. Okay. Okay. So let's look at the first one. Y equal to 4x squared, which is drawn over here. Does it have maximum or minimum? It has a minimum. We'll just write MIN for short. Turning point. What's the point of the turning point? Turning point is here, which is 0, 0. Origin. Find the y value when x equal to 1. So you substitute 1 into x. What will your answer be? 4. Yes, you get 4. And then the next question is you have to look at it. Is it more narrow or wider compared with the first one? It's more narrow. So when you have a 4 in front of x squared, it makes the parabola more narrow. Okay, done. All right, once we do this, we'll look at the next question. Next question is this. Okay, so part B, y equal to x plus 2 square. So it's been shifted to the left, right? So we shift to the left. How many units? 2 units, isn't it? Okay, so let's look at does it have maximum, minimum? It still has a minimum. And then what else are there? What's the turning point? Anyone? Turning point? That one, what's the turning point? Alright, -2, 0. Very good. Then we're going to find the y value when x is 1. Let's substitute y equal to 1 plus 2 squared. What would that be? Cameron, what would that be? 4. You won't get 4. 5. Now remember, mod mass, you work out what's inside the bracket before you square. What would that be? What would that be? Say again? What did you get? 9. Okay, good. Alright. So when x equal to 1, y equal to 9. Okay, is that more narrow or wider? It's actually the same. So basically, if there's no number here, it doesn't make it more narrow or wider. It's the same graph, just being translated to the left. Okay, let's look at the last one. Okay, last one's over here. -x squared plus 3. So what's the max or min? It's max, right? Because it's concave down. And you will see that when there's a negative, it's concave down. When it is positive, it's concave up. So maximum turning point, what would the coordinate of turning point be? Jaden? 0, 3, good. Let's find the y value when x equal to 1. What would it be? Let me ask Gordon. What's the y value when x equal to 1? 2. Okay, good. And is that narrow or more wider? Same, should be the same. Okay. All right, good. So we see these 3 examples. So just remember, if there's a negative, it's concave down. Positive is concave up. And that's all. Okay, so we'll do the next page, next lesson. So today just do exercise 9A. Thank you.